Alright, take a crack at this one. I'm going to start it now. We want to find dy dx for the parametric equations, and then it's these two equations. First thing you'll notice is that there's no direct relation between y and x. So trying to get this y and x would be a challenge, right? But there is one way these two are related. And how is that? Well, they're related by the t variable, right? So one way we can approach this problem is to find their derivative of each one with respect to t, and then divide them by each other. And your result, because these t's will kind of like cancel, is dx dy. This is like a kind of a use of the chain rule, right? Like you're taking derivatives with respect to t, and then because they're both in respect to t, you can get derivative of x with respect to y. Okay? Hope that makes sense. So let's get started. Now that we know what we need, we're going to go ahead and get dx dt. And these are simple one variable derivatives. You would multiply that by 2, drop down the exponent, and this will become a 1 because the coefficient's 1. dy dt. This exponent will come down, become a 2. This t will drop out, it'll become a 2, and that 1 will become a 0. So now you have your dy dt, and you have your dx dt. So, oh, that's dx dy. You want dy dx. Well, this is a little bit wrong. You just have to switch these around. Since we want dy dx, you would have dy dt over dx dt. Okay? So, switch my color to blue. We will take dy dt, dy dx will equal our dy dt. We plug that in. 4t minus, oh, screwed up again. dy dt, plug it in right here. 3t squared minus 2 over dx dt. So this one's going to that one, that one's going to this one. 4t minus 1. And you don't really need to simplify it any further. Generally, on the test, they won't make you simplify too much because they want to save time. They want to hit you with as many questions as you can get, you know. So, I hope that makes sense.